In many Hollywood films, we often see a scene where someone steps into a special kind of portal, and within moments, they emerge far away through another portal. This concept is known as teleportation, and researchers have now discovered something fascinating: it might actually be possible. Today, I'm going to take you through some of the most interesting aspects of teleportation. In order to reach faraway places quickly and easily, there have been numerous experiments and research projects in the field of transportation. Over the years, we've developed faster trains, vehicles, and airplanes to shorten travel time. If we look back through human history, the earliest wheels appeared around 3500 BC, marking the beginning of our journey toward faster and more efficient transport. From simple carts with tires to ships and airplanes, our methods have evolved across centuries. Today, the fastest way to travel is by airplane, but even then, long journeys can take 3, 5, or even 10 hours. Imagine if we could cover such distances in just a few seconds, something we often see in science fiction movies. In those scenarios, you step into one portal and instantly step out of another, hundreds or even thousands of kilometers away. In simple terms, that's teleportation. You might wonder, is that even possible? How could we cover a journey that normally takes hours in just moments? Consider how communication has evolved. There was a time when telephones were connected by wires, and calling someone far away was slow and limited. Today, with mobile phones, we can video call someone instantly. 100 years ago, people would have said that was impossible. Teleportation is in a similar stage now. It exists as a concept, but it may one day become reality. When we look at how teleportation could be possible, scientists see two main approaches. The first involves wormholes. According to Albert Einstein's field equations, wormholes are shortcuts through space-time. They theoretically connect two distant points in the universe, allowing instant travel between them. Though we have not yet found an actual wormhole, physicist Stephen Hawking once explained that at extremely tiny scales, smaller than molecules or atoms, space-time may have wrinkles and tunnels. If we could find such tiny wormholes, enlarge them, and keep them stable without collapsing, we could travel vast distances in very little time. However, enlarging wormholes would require infinite energy, so for now, wormhole-based teleportation remains only a theory. The second possible method is through quantum entanglement. In 2012, physicist Anton Zeilinger teleported a photon from the island of Tenerife to La Palma, 143 kilometers away, not using wormholes, but by using quantum entanglement. Quantum entanglement occurs when two particles become linked in such a way that changing one instantly changes the other, no matter how far apart they are. We still don't fully understand how or why this happens, but it works at the quantum level. If two entangled particles are separated, one kept nearby, and one sent far away, and an object's data is encoded into the first particle, that information instantly appears in the second particle. The original object would be destroyed in the process, but with the data received, it could be reconstructed at the destination. In science fiction terms, this is like stepping into one portal, vanishing, and instantly reappearing at another location. Quantum entanglement teleportation has already been demonstrated with particles. In 2017, Chinese researchers teleported a photon to a satellite orbiting Earth, and in January 2023, scientists successfully teleported energy. However, there are still major challenges. For one, the entanglement must remain perfectly stable over long distances. Second, teleporting large objects is far more complicated. Every particle in the object would need to have its position and structure precisely transferred, otherwise, errors would occur. If any of that data were lost, the recreated object would be defective. Currently, we're still in the learning phase. In quantum physics, we cannot yet measure both the exact position and motion of a particle at the same time. But as technology advances, new breakthroughs will come, and one day, technologies like teleportation could become a reality.
Subscribe for more videos. Thanks for watching.